Section 6.1 deals with area between two curves. Now we've looked at area under a curve, and we know that the definite integral represents the sum of the signed area between the graphs of y equal f of x and the x-axis from a to b. So if we look at this, and let's call this guy f of x, let's call this a, and let's call that b. Well, we know that everything that lied underneath the x-axis was considered something negative, and everything above the x-axis was considered something positive. Well, we also know that area is not negative, so what we're going to do is we're going to learn how to find the actual area between curves on the x-axis, because we're always going to end up with non-negative quantities. So the area between two curves. If f of x and g of x are both continuous functions, where f of x is bigger than g of x on a closed interval ab, so here is my f of x and here is my g of x, and notice that f of x always lies above g of x from the interval from a to b, then if I'm looking for this area, the area between these two curves, the area is always going to equal the integral from a to b of f of x minus g of x dx. So it's always going to be the bigger or the upper curve, in our case f of x, minus the smaller or the lower curve, in this case g of x. So let's practice setting this up, because that's the most important part when you're finding the area between two curves. Let's say that I want to find the area between these two curves, and I'm told that this is my x-axis here. This, if we can't see it, and I'm going to draw it in a different color, this line right here represents g of x. So this is my g, and then that blue line, which I'll trace over, represents f. So I want to find the area between these two curves. Well, in order to find the area between these two curves, my area is always going to equal the integral from something to something, where it's always going to be the bigger curve minus the smaller curve. Well, notice from x equal a to x equals c, the blue curve is bigger than the red curve. So if I wanted to find that yellow area that I have highlighted there, it would be the integral from a to c of the blue curve, which is f of x, minus the red curve, which is g of x dx. But that only takes care of this first little piece here. Notice in our second piece, the red curve is on top of the blue curve. So from x equals c to x equal e, we would say that the area would be g of x minus f of x dx. So to find the area of the whole entire highlighted curve, it would be the integral from a to c of f of x minus g of x dx, plus the integral from c to e of g of x minus f of x dx. The most important thing to understand when you're finding the area between curves is that it's always going to be the upper or the bigger curve minus the lower curve. And to understand that it might not always be the same curve that lies above, so you might sometimes need to find points of intersection to figure out where you have an upper curve and when you have a lower curve. So let's look at some examples where we're finding the area between two curves. So we want to find the area bounded by the graphs of the indicated equations over the given interval. So we want to find the area bounded by y equals negative x plus 10, y equals 0, from negative 2 to positive 2. So if I were to graph this, well, y equals negative x plus 10. This guy here is just a line. I know that my slope is equal to negative 1 over 1, and that my y-intercept is equal to 10. So here, 10 is my y-intercept. And I know my slope is equal to negative 1 over 1. So I go down 1 unit and 1 to the right, and again down 1 unit and 1 to the right. And I'm just going to make a few points to help me graph this line. And I can also go up 1 unit and 1 to the left to add more points. So I'm going to go ahead and graph this line. So this is the line of y equals negative x plus 10. And then I also need the line y equals 0. Well, the line y equals 0 is just that x-axis, right? It's a horizontal line at the x-axis. So here's my line y equals 0. And I want to find the area of the region bounded by these two graphs and between x equal negative 2 and x equal positive 2. So here is x equal negative 2, and here is x equal positive 2. So I want to find this region right here. Well, the area of this region is going to be the integral from negative 2 to positive 2 of the top curve. Well, my top curve is this blue curve, which is my negative x plus 10, minus the bottom curve. Well, the bottom curve is this red thing, which is just 0 dx. So if I work this out, well, if I combine like terms here, negative x plus 10 minus 0, it's just going to be negative x plus 10. If I integrate this, I have the integral of negative x. Remember here my n is equal to 1, so this is going to be negative 1/2 x squared plus, here this is a constant and it's equal to 10, so plus 10x, and this gets evaluated from negative 2 to 2. So plugging this in, upper limit of integration, we get negative 1/2 times 2 squared plus 10 times 2 minus lower limit of integration, negative 1/2 times negative 2 squared plus 10 times negative 2. Okay, so let's just plug this into a calculator. So I have parentheses negative 1/2 times 2 squared plus 10 times 2 minus parentheses negative 1/2 times negative 2 squared plus 10 times negative 2. Hit enter and we end up with 40. So the area that's bounded by the graphs of y equals negative x plus 10, y equals 0, between negative 2 and 2 is equal to 40. Let's do the same thing for number 2. We want to find the area bounded by the graphs of y equals negative 2x squared, y equals 0, between negative 6 and 0. So let's go ahead and graph this. Well, I know that I have y equals negative 2x squared, y equals 0, and then graphing it between negative 6 and 0. Well, I know that this is going to be a quadratic that opens down, and if you think about what happens when you plug a negative 6 in place of x, you'd have negative 2 times a negative 6 squared, or negative 72, so you know you're going to be going pretty negative on this graph. So it's a quadratic. Again, its vertex is 0, 0. I know it goes down 2 units and over 1, both left and right. And here at negative 6, I know that this is going to be negative 72. And it's okay that it's not drawn perfectly. We're just using the graph to try to set up our integral. Y equals 0, again, is just the x-axis. So this is the graph of y equals 0. And again, we're looking between negative 6 to 0. So the area between negative 6 to 0. So we're trying to find this area right here. Well, that area is going to equal the integral from negative 6 to 0 of, well, our top curve is 0 minus our bottom curve is our negative 2x squared dx. Okay, so if I clean this up before I integrate it, well, 0 minus a negative, well, I don't need that 0 there, and minus a negative just becomes positive. So we're looking at the integral of 2x squared dx. Well, I know 2 is just a constant multiplier, and then it multiplies along. And the integral of x squared dx, well, here my n is equal to 2, so it's going to be 1/3 x cubed, and this gets evaluated from -6 to 0. So if I plug in my upper limit of integration, I have a is equal to 2/3 times 0 cubed minus, if I plug in my lower limit of integration, I get 2/3 times -6 cubed. Plugging this into the calculator to find the answer, you're looking at 2/3 times 0 to the third, and that gets subtracted from 2/3 times -6 to the third. And I end up with 144. So the area that is bounded by the curves y equals -2x squared, y equals 0, from -6 to 0 is equal to 144.